the exact value of cot theta. We want to make note also that theta must be less than 180 and it should be greater than 90 degrees. And this is telling us something because we just want to take a quick look here. This is 0, this is 90, this is 180, and this is 270. And then we go back to 360 here. We're looking at the fact that this is our first quadrant, this is the second quadrant, this is the third, and this is the fourth. What we want to do is to remember, though, that you could see the first quadrant is between 0 to 90, the second quadrant is between 90 to 180, the third is between 180 to 270, and the last, which is the fourth, is between 270 to 360. In addition to that, we want to make note that all the trig functions are positive in the first quadrant. Sine is the one that is positive in the second. Tangent is the one that is positive in the third. And cos is the one that is positive in the fourth. So apart from those that are positive where they are, everybody else will be negative. So let us take a look at the question. If cos of theta is equal to -1/2, then cot theta should be what? Remember our constraints were between this. And this suggests that let us get a right triangle. We need to get a right triangle so that we could actually complete the triangle first. So if I should put the angle theta here, remember, so, ka, taw. This still stands, right? So it is telling us that cosine is adjacent over the hypotenuse, this one. So cosine of this angle theta is 1/2, right? The adjacent leg, the hypotenuse leg. The reason why this is negative is because we are in the second quadrant and sine is the only thing positive there. That is why the cosine would have had to be -1/2. Now we're going to complete the triangle to find this missing side here before we could answer the question. So let's take a look. Using Pythagoras theory, this short side square is going to equal to the longest side, which is 2 squared minus 1 squared. What we're looking at is 4 minus 1, and this is 3. So x is the root of 3. A lot of times, this side is actually a side that everybody kind of know offhand, but I just showed you how to complete it nonetheless. So this side is the root of 3 in context of what this angle is right there. So at this moment, what we want to do now to get the exact value of cot is to remember what cot is. Cot is actually the inverse of tangent. And tangent says the opposite side must be over the adjacent side. So if I'm going to go cotangent, which is cot, I'm going to reciprocate that ratio. So I'm going to have for this the adjacent side over the opposite side, which means that the adjacent side is 1 and the opposite side is going to give me the root of 3. Ordinarily, we're not going to leave the radical in our denominator. So we're going to multiply the denominator and the numerator by the root of 3. So at the numerator, we're going to have 1√3 over root 3 times root 3 give us 3. So the cot of this angle is √3 over 3. But remember, though, that this is negative, right? So we're in the negative because tangent is negative in the second quadrant right here. So this quadrant, so we're looking at -√3 over 3. Thank you. Let's look at another problem. All right, so in this second problem here, we have cosecant of theta is 4/3, and we want to find sec theta. We're still between 90 and 180. We're in the second quadrant, as you could see, right? So firstly, we want to complete the triangle, but we got to make sure that we put on cosecant first. So let us get up our right triangle. So if this is my angle theta, remember cosecant is actually the inverse of sine. So if we look back at so cat tower, so is for sine, which suggests that we're dealing with the opposite side over the hypotenuse side. Now, the inverse of sine is cosecant, which means that cosecant of the angle is going to be the hypotenuse over the opposite side, which means that 4 over 3 is reflecting that. So the hypotenuse was 4, and the opposite side to that angle was actually 3. So now we have this. What we want to do is to complete the triangle. We want to find this side first before we respond. So we're going to use Pythagoras theory and say x squared, which is the one of the short side, is equal to 4 squared minus 3 squared. So this is going to take us to 16 minus 9, and this is 7. X will be the square root of 7. So we're going to put the square root of 7 here. Then we're going to respond to the question. We want to find sec, right? But at the same time, we have to remember what quadrant we are in. We're in the second quadrant, right, as we speak. So let us take a look at what's going on. Sec is the inverse of cos. So cos, ka, right, is saying that the cos of the angle is going to equal to the adjacent side over the hypotenuse side. Therefore, the inverse of it, which is the secant, is going to give us the hypotenuse over the adjacent. So in a response to this question here, we want to grab so we're saying that sec theta is going to be the hypotenuse, which is 4 over. The adjacent side to this is root of 7. We're going to have to rationalize, so we remove that radical from our denominator. And what we're looking at now is 4 root 7 over 7. Remember, though, that this is the inverse of cos. So sec and cos, they're negative in the second quadrant. So this is our response right there. All right, so in this question, we're actually now in the fourth quadrant because we're between 270 and 360. In this quadrant, cos is the only trig function that is positive. All right, so that is why even this question start off with tan being the negative because we're in the fourth quadrant. Now let us drop our triangle. And what we're gonna do, we're gonna put on this. So tangent is so ka to. So the tangent of the angle is equal to the opposite side over the adjacent side. So it means if I have 1/4, then 1 is the opposite. So if I put the angle here, the opposite is a cross form. That's 1, and the adjacent is 4 next door. Now, why this is negative? It's simply because this angle is in the fourth quadrant. So we're not going to put negative on the diagram, but we know we're in the fourth quadrant. So now let us complete the triangle. Let us say we call this side x. Then it is the longest side, so it is the hypotenuse. So what we're going to say is that x squared is equal to 1 squared plus 4 squared. This is 1 plus 16, which is 17. X is equal to the square root of 17, which means that we're going to put the square root of 17 here. From this, we could now respond to this because the triangle would have been completed. We want to bear in mind that we're in the fourth quadrant and cosine is the only trig function there positive. Already, I know that my answer for this would be a negative number. Let us look at the sine. The sine of an angle in that right angle triangle is always the opposite side over the hypotenuse side. So the opposite side to this angle is 1, and the hypotenuse side is the square root of 17. We're going to have to rationalize 17, and what we're looking at finally is the root of 17 over 17. So we're looking at the root of 17 over 17, and we're done. Remember now that it's going to be negative because we're in the fourth quadrant, right? So there it is. We have done that. Let us take a look at the last problem. All right, so the fourth problem and last, we're finding sec theta is the root of 15 over 3. We want to find the cosecant of theta, and we're between 270 to 360, which means that we're in the fourth quadrant, and cosine is positive. Cosine is positive in that quadrant. Now, let us take a look at what we're going on with here. So we're going to always get our right triangle, and we're going to put on this. Let us say we put our angle here. We're going to fit this on. We need to relate what cosecant is, what secant is, should say. Remember, secant is linked to cos. Cos is adjacent side divided by the hypotenuse side. Secant is actually the inverse, which means that we're going to reciprocate. So we're going to have the hypotenuse over the adjacent. Then I could label the first two legs of my triangle using this. So it means then that this that I have here, the root of 15 over 3, is, in sync. So the hypotenuse is the root of 15, and then the adjacent to this angle is 3. I can now use this to find the third side here. It is a short side, so the short side square is equal to the root of 15 square. And we're going to subtract from that 3 square. The root of 15 square will cancel, so we're left with 15 minus 9. And this is going to give us about 6. So this is going to give us 6. So x is going to be the square root of 6. So this side here, my third leg, has a value of the root of 6. Now, having found this, then we can now respond to the question by finding the cosecant. Cosecant is the inverse of sine, right? So cosecant is the inverse of sine. Let us just clear this and drop this right here. So cosecant is the inverse of sine. So let's take a look at what sine is. Sine of the angle would have been the opposite side over the hypotenuse side. But if I'm going to go cosecant, it simply means then I'm going to reciprocate, which is going to be my hypotenuse over the opposite side, right? So that is what I'm looking for now. So in context of what we're doing, the hypotenuse is 15, well, the root of 15, and we're going to put that over the opposite side, which is the root of 6. Depending on your level, what you could do with this, you could break this to show that it is 15 over 6. And if you divide by 5, 5 into the 15 is 3, 5 into the 6 is 2. So technically, not 5. You could divide by 3. Let me just repeat that. We could divide by 3. 3 into the 15 is 5, and 3 into the 6 is actually 2. So basically, you could have root 5 over root 2. Let me just fix this better. We're looking at the root of 5 over the root of 2, and then we rationalize root 2 over root 2. So this is going to give me root 10, because you could multiply these radicals. It could be multiplied. So the 2 times 5, that's 10. It's going to be over 2, and this is going to be your final answer. You got to bear in mind now, are we positive? Are we negative? This is actually linked to sine, and sine is negative in the fourth quadrant. Do not forget to put your sign So our sign is very relative to where we are, what degrees are we between. All right. So that is how we find the exact value of trig functions. Right. Take care.